Bienvenidos a su programa de Cabeza. Hoy, sin duda alguna, traemos a sus televisores, a las pantallas donde se encuentren una de las mentes más provocativas que yo he leído. Y no solo ello, una gente que está revolucionando al mundo. Como lo dijimos y lo diremos, hace 60 años se descubrió lo que es el ADN. Probablemente 15 años entendimos la secuencia del genoma humano. Pero hoy hay alguien que está revolucionando el mundo al traer las secuencias del genoma a la psicología. Él es Robert Plomin. Su libro, uno de sus libros es Blueprinto. Una confesión. A mí mucha gente me dice, oye Andrés, recomiéndame un libro, y la verdad, si no conozco a la persona, trato de evitarlo. Recomendar un libro es como a veces, y sobre todo cuando no conoces a la gente, es como presentarle a alguien con quien salir. Debo saber tus gustos, tus apetitos, tus intereses. Por eso trato de no hacerlo. Pero con este libro hago una excepción. ¿Por qué? Porque este libro trata de ti, y de ti, y de ti, y de todos nosotros. ¿Por qué? ¿Por qué tenemos sobrepeso? ¿O por qué no lo tenemos? ¿Por qué nos divorciamos? ¿Por qué está mal que digamos que hay enfermedades de gente anormal? ¿Qué significa realmente ser inteligente? ¿Qué tanto sobreestimamos lo que los padres proponen y educan? Y hablamos de crianza a los hijos. ¿Qué tanto sabemos de nosotros mismos? Esta es una obra polémica, brillante, astuta. Robert, thank you very much to be with us. It's a great honor to have you in our program. Welcome.
Wow, I should just quit there. I can't do any better than that.
No, I mean, I have to tell you, as I mentioned to you before, I'm impressed. I thank you very much. And welcome to Upside Down. Before we begin, share with us, because I was telling you the last time that we were talking, that I thought you were like 95 years old when I was reading that you went to the Soviet Union, when the Soviet Union actually was very afraid to talk about genetics and hereditability, and you were the one that brought it. Your projects in Sweden, your projects in Colorado, your projects with Minnesota kids, etc. Tell us about you and how did you got involved on this amazing topic. Welcome to the program.
Well, thank you very much. What a wonderful introduction. There's a long story. A lot of the book, Blueprint, describes my history. It kind of intertwines my history with the history of this field, behavioral genetics, because I was there sort of at the beginning of the field in the early 1970s. And I've gone along with it, and now we're into the DNA revolution. So I feel very lucky I was in the right place at the right time. But part of the story, in addition to genetics being important, part of the story is the environment's important. But the way the environment works is much more like chance than systematic factors. And that's something very important for people to know. If you look back on your life, I've read a bit about your life. I think you might agree with this. Most people do. As I look back on my life, there were some chance events, some tipping points. And one of them was that I went to the University of Texas at Austin. And I grew up in inner city Chicago, where no one went to university, let alone graduate school. And I had this wonderful advisor who helped me apply for graduate school programs. And then Texas wrote to me and said, we'll pay you to come. So as an inner city Chicago boy, I thought, can't beat that. So I decided I'd go. But I knew I was interested in psychology, but they had the only program in the world, the course in behavioral genetics. Nowhere else was that available in the 1970s. And so just by chance, I took that course, and I don't know why, but it completely floored me. I just knew that's what I wanted to do. I just thought it was very powerful, and it was novel in the sense that in all my graduate psychology courses, no one ever mentioned genetics. It was all environment back then. Even schizophrenia, we were taught in the textbooks, it's caused by what your mother did to you in the first few years of life. Genetics never got mentioned. And partly I think I got into it because I'm tough in a way, in the sense that back then it was dangerous to even talk about genetic influence in psychology. And so I was able to tough that out, and I thought we'd collect the data and just convince people who were empirically oriented that genetics is very important. And it also tells us a lot about the environment. And so for 30 years, I've collected data from twin studies, comparing identical and non-identical twins. You mentioned one of those studies, as well as adoption studies. In Sweden, we studied identical and non-identical twins reared apart. All of these data converge on an amazing conclusion, and that is everything in psychology shows genetic influence. It also shows that genetic influence is never 100%. It's more like 50%. And what's the other 50%? Well, it's non-genetic, but it's actually, we call it environment, but it's a very broad definition of environment that can include accidents, illnesses, biological factors. It's just not due to inherited DNA differences between us. So this mountain of evidence convinced most psychologists, behavioral scientists, that genetics is important. And so I thought after 30 years, that was good enough. But then the DNA revolution came along, which I'm sure we'll talk about later. And we can now identify some of the DNA differences that predict these behavioral traits. And that's going to change everything: parenting, society, the way we think about ourselves. 25 million people have paid to have their DNA genotyped, in part for these reasons. So I was in the right place at the right time. And I think there's been a tremendous sea change in how people feel about genetics. It's much more accepted in psychology than it used to be. Education is still a bit of a holdout. You know, they still don't like the idea of genetics. And yet, education is where we see the most influence of genetics, in educational achievement, for example. So it's been quite a ride, and I can't quit, because now that we're beginning to find some of the DNA differences, it's so exciting. You know, I couldn't possibly stop doing it now, because this is, for 15 years, I've been trying to find the DNA responsible for all this genetic influence. And we just didn't have the technology until about 5 years ago, really. And I can explain that technology, but it really has transformed our ability to find DNA differences associated with behavior. So it's just been, as I look back on my life, I just think, wow, it just is amazing that I was just there at the right time, and I was along on the ride the whole way, and it's accelerating now with the DNA revolution.
Well, Robert, of course we will talk about your findings, but probably after reading your book, to be there at the right time probably had also a genetical influence of your appetite that you had with yourself to eat that kind of opportunities. Before we go to the topics...
I think that's a very good point, you know, that I was maybe a bit too modest about it, but I was really turned on by behavioral genetics, but I was with 39 other graduate students taking the same course. Not one of them became interested in it. I don't know why I did, but I do think you sort of make your own environment. That's another major finding in this area. We call it the nature of nurture. It's not that the environment's imposed on us. We create our environments. We select environments correlated with our genetic propensities. And I think that's how genetic influences work.
Well, I would love to talk about that, because I think it's all your book is about counterintuitive things. I mean, goes against intuition. That's one of the most amazing things about your work. It's go against what you expect. But before we go to your big discoveries, and one has to do with that one that you just mentioned, nurture versus nature, and how much actual environment is substantially genetic influence in it. Why, for the people that are listening to us, why it is important to have identical or not identical twins reared apart, and that's the better way to understand. I want to talk a little bit about the method of the conclusion. And if you mention a little bit about what you have discovered in terms of technology the last 5 years, to make understand everybody that what we're talking about, it's pretty sound, and the way that it could really be scientifically.
Yes. Well, there are two major methods: the twin method, which you just alluded to, and the adoption method. The twin method is like a biological experiment where 1% of all births are twins. But most people know there are two types of twins. 1/3 of twins are identical twins, monozygotic. It's a single zygote, a single fertilized egg that divides after the first few days of life. And those two separate zygotes are monozygotic in the sense that they're genetically identical. They're clones of one another. The other type of twin is called non-identical or fraternal twins, and those are like any brother and sister who happen to be born at the same time. That is, they're separately fertilized eggs, and they share 50%. They're 50% similar genetically. So if genetics is important, the twin method just says identical twins ought to be more similar for their trait than non-identical twins. Okay, so that's the twin method. The other method is the adoption method, which is like a social experiment. Things run in families. We've known that for centuries. So obesity runs in families, and intelligence and psychopathology. It runs in families, but it was always assumed that that's due to nurture, environment. And that's a reasonable assumption. If you think about body weight, you can see it runs in families. People have always assumed it's due to nurture, environment. And that's not dumb, because you know that parents provide the food the children eat, and they model nutritional, dietary sorts of things, and also exercise and lifestyles. But it turns out it's genetic, and the adoption method this is a good example of the adoption method. You can study if parents and offspring share nature and nurture, how can we separate nature and nurture? And the adoption method does it with a social, experiment, in the sense that you study children who are adopted away at birth from their biological parents. They share genes, but not environment with the parents. And if genetics is important, you'd predict that the children are similar to their biological parents. Those children are adopted by adoptive parents who share nurture, but not nature, environment, but not genes with the kids. And if it's environmental, if it's nurture, the kids ought to resemble their adoptive parents. So parents and offspring correlate about 0.3. Correlation is an index from 0 to 1. They correlate 0.3 for body weight, body mass index, which is weight corrected by height. Well, is it nature or nurture? Well, if it's nurture, what's the correlation between adoptive parents and adopted children? The answer is 0. Those adopted children don't at all resemble their adoptive parents who give them their food and model environments. So is it genetic? And the answer is yes. Those adopted children's weight correlates as much with their birth parents as kids who are reared by their biological parents. So the adoption method's another powerful method. And then just finally, you mentioned identical twins reared apart. That's a combination of twins and adoption. They're quite rare, but there is a fantastic film that won a Sundance Award for documentary last year called 3 Identical Strangers. I think it's actually in Spanish as well, but it's streaming on major services like Netflix and Amazon. So it's really worth seeing, because it's a story you might have heard about where 3 identical, there's triplets, sometimes identical twins divide again so that you get 3 clones. And in this case, these 3 men didn't know the others existed till they were 19 years old. And it's the story of them coming together. And it's a very dramatic illustration of the power of nature. You can't tell these 3 apart physically, but it's not just physical, it's also personality. They're all very outgoing. Psychopathology, they're all quite depressive. They were all 3 treated for depression as an adolescent, which is very rare in adolescents to be treated for depression. This is before they knew of each other's existence. And they were also similar in educational achievement. They were a type of kid you may know at school. They're very bright, obviously. They like to read. They just didn't like school. They didn't like to be told what to study, for example. So when they got together, they all quit university, and they moved to Manhattan, and they set up a nightclub called Identical Triplets, and it made $1 million in the first year. So they found their need.
Actually, we're inviting them, well, the 2 of them, because as you know,
Yes.
one of them passed away, and that's interesting. Even the 3 of them they have a big propensity for depression, and they were born in July 12th, by the way, the same day I was born, which has nothing to do with it. But when I read the story that they were born in 1959 and that one passed away and actually killed himself, my question that came was, okay, even that genes are very important, there is also environment and the way you actually translate what you're living. But before we go to that discoveries, because they're extremely interesting, in your book, in the first pages, I will read it immediately, just in Spanish, just for the people. I mean, señoras y señores, en su libro él dice, el color del ojo, de los ojos, los resultados de la razón genética de la herencia es el 95%. La gente cree que es el 77%. La altura, las genes son 80%. Nuestro sobrepeso o peso que tenemos, 70%. La esquizofrenia, 50%. Nuestra inteligencia en general, el 50%. La personalidad que tenemos, el 40%. Es decir, los genes pesan mucho más de lo que nos imaginamos por la percepción. Now, my question for you, Robert, I mean, I'm just translating the first pages that then you make a question. Well, please make your own guess and then you come with the answer. Here there was an outlier in these first pages to start about your findings. And that was, for me, was surprising. Breast cancer. I mean, before reading your book, I thought breast cancer had a very strong genetical influence. And it says 10%. That was an outlier. Could you elaborate a little bit?
Yes, it's a good example of the need to assess rather than assume what's heritable. So with breast cancer, people say it's very highly heritable. I forget what it was, 80% or something like that.
53, yes.
But then, in fact, it's much less than that. It's 10%. Identical twins, women, if one identical twin gets breast cancer, the other only has about a 14% risk. The base rate is 10%. So there's hardly any increased risk. It's a very small increased risk for having a clone, a genetically identical individual, get breast cancer. You ask people, well, why do you think it's so heritable? And that's because they hear about these genes for breast cancer, Angelina Jolie, for example. But those genes, there are 3 genes that have been found, but they're very rare genes, and they're very severe. I mean, the worst of them creates early onset bilateral ovarian cancers. It's a really bad mutation, but it is very rare. And so actually genetics doesn't count for much in terms of who gets breast cancer or not, which is a great example of the need for this sort of research. In general, cancers show less genetic influence than most other medical traits like cardiovascular disease. And that's in part because cancer involves DNA. This makes an important point, I think, but it's not inherited DNA differences. The sun causes, if I have any propensity towards skin cancer, I'll get it because I'm a sun worshiper. I love to be in the sun. And what the sun can do is cause mutations in your skin. And that mutation involves DNA, but it's not inherited. It's caused by the environment. And so that's counted as environment. It's not counted as inherited DNA differences. So the other point I need to make here, just to make sure people understand, is we're talking about why people differ. So we have 3 billion base pairs of DNA in the double helix of DNA. And 99% of those DNA sequences are the same for all of us. That's what makes us human. We're talking about just 1% of those DNA differences that differ between us because we're asking to what extent does genetics, inherited DNA differences, make a difference in our personality and psychopathology and mental abilities and disabilities. So we're only talking about differences in the population. When we say weight is 60% heritable, we mean that 60% of the differences between people in weight is due to inherited DNA differences. It doesn't mean that if I'm 2 meters tall, I grew to 1.6 meters because of genes and the environment added the other one. I mean, that sounds silly, but you'd be surprised if you scratch the surface of what people know. There are great misunderstandings about what heritability means. So the main thing to emphasize was we're talking about differences between people, what makes people differ.
And this is extremely important because, I mean, one thing is genetics, that, what, as you mentioned it, I mean, I was born with 2 legs and 2 arms and 2 eyes, and that's important, but that's genetics. This 1% of difference is what makes me very different to other people in terms of personality. And as you have mentioned it with bananas, I have 50% that I share actually the same genes. Just for the people to understand what we're talking about. And we will talk about intelligence in that sense. If you allow us, we will have 2 programs with you. And the difference between within groups and between groups, because I think that's extremely important that we talk also. But before we go there, you have found, among other things, like 5 outstanding discoveries. I would like if we could talk one by one, little by little. First, the idea of nurture versus nature. And you, in your book and in your papers, you have talked about the 3rd factor. So if you could mention a little bit, because most of the people believe that, okay, I have 50% of hereditability and 50% of environment. But at the end, what we have believed and understand about the environment, how we choose the people that we get with, why our parents actually were much more nicer or kinder with one of our siblings. Many things that you mention in the book. Don't believe everything you think. This is not environment. This is because since your inheritance, you brought some things to the table that make you be in a special way, that you look for that kind of friends, or you're in a way attracting that kind of love from your parents. Could you please, because that's a great discovery, the first finding, nurture versus nature.
Yes, we actually call that the nature of nurture, because it started when in the early 1980s, I almost mistakenly took environmental measures, like how parents treat their kids. You know, we observed parents interacting with their young children in the homes, and we rated the parents on how supportive they were and nurturant and all of those sorts of things. And it was in an adoption design. And what we found was evidence for genetic influence. And at first you think, well, that's a mistake. It's an environmental measure. How can it be genetic? But it actually, since then, there's been hundreds of studies of that sort. And what they find is environmental measures that are widely used in psychology show almost as much genetic influence as behavioral measures. You know, and that sounds crazy. But if you think about it, the measure that's used most in studies is life events. Things happen to you. And, you know, you'd think, well, that doesn't have anything to do with genetics. Well, but it does. Life events shows about 30% heritability. And that makes it is incredible, isn't it? But then you think about it, what goes into that? What these items on the life events questionnaires are things like lost your job, got in conflicts with people. These are not the environment out there independent of us. This is the way psychology used to think. It was called stimulus response theory, like rats in a cage are shocked or starved, and that changes their behavior.
Robert,
but our
in that
environments
sense,
aren't like that.
In that sense, I was surprised. Please, first of all, I would like to invite you to another program, because 30 minutes with you is 0, it's nothing. Before we end this program, following that line, the difference between accident and accidental. That's amazing.
Exactly.
Could you elaborate a little bit?
Yes. You know, people are really, psychologists are stuck with this view that the environment is out there. It's what happens to us. But I'm convinced that the reason all those environmental measures show genetic influence is because the way genetics works is to have us select environments, create environments, change environments in a way that fits our genetic propensities. We find environments that suit us. And, you know, I think that's such an important point, because for parents and teachers, what we want to do is find out what kids like to do and what they're good at, their appetites and their aptitudes, and help them find, you know, do what they like to do and what they're good at, instead of imposing on them some preordained notion of what we want them to do. I mean, some parents still stupidly think they're going to make their kid into an Olympic athlete or a world-class musician, for example. And you can help your kids develop athletically. You can help your kids learn music. But, with a little bit of experience, you see kids differ so much in their abilities. And, I think it's much better to go with the flow of genetics, figure out what kids' appetites and aptitudes are and help them do that. So that it's not to say you can't do anything. It's just don't do things for your kids because you're trying to make them into something. Do things for your kids because you love them and you want life to be nice for them. So I think it's such an important point. And to realize that kids make their own environments to a large extent. And here's another aspect of this that I think is really important. I don't know if your listeners know the adage, correlation does not imply causation. And so it drives me nuts when I look in the newspapers and they're trying to make parents anxious. So they say, parents who do this have kids who are like that. For example, parents who read a lot to their kids have kids who do better at reading at school. That's a correlation. It's reasonable to think that the parents reading to the kids causes the kids to read better when they go to school. But if you get the genetic message, you'd say, actually, reading ability is highly heritable. And it could be that parents who read a lot, have lots of books in their home, have kids who are genetically more apt to learn to read and to like to read.
Genetics describes what is, but it doesn't describe that what could be. And we'll talk about that in the next program. It's an honor to have you, Robert. Muchas gracias.
Muchas gracias.
Hoy fue Robert Plomin. El próximo domingo, la segunda parte de esta interesantísima personalidad. Y, ¿por qué no?, de sus importantes ideas. Quédese en ADN 40, aquí, en su canal. Buenas noches.